Okay, 9.3 day one. We're going to do trig functions with quadrant restrictions. Since we're graphing angles now, they're going to give us ordered pairs for our angles. And we're going to find the sine, cosine, tangent, and other trig functions of them based on that. So I'm going to draw you a picture so you can see why this works. Okay, so it says let theta be an angle in standard position. XY is a point on the terminal side. So let me pick a point that's going to be XY. I'm picking this randomly just to show you the numbers. It's my ordered pair XY. Theta is the angle in standard position. So I'm going to go ahead and draw. This is my terminal side. This is theta right here. Okay, you can see there's a triangle here, so I'm going to go ahead and bring down the altitude so that there's a right angle here. The thing to notice is this is 0, 0, because this is in standard position. So if I go to the right, how far am I going? I'm going to the right x. After I go to the right x, I go up y because that's the y coordinate. And then I need a variable for the hypotenuse, so I'm going to call that r real quick. Okay, now we're going to write the ratios based on this, and then we'll worry about the r in a second. Okay, so if we do sine of theta, that's going to be the opposite over the hypotenuse, so we call that y over r. For cosine, that's the adjacent over the hypotenuse, so that's going to be x over r. And then tangent is opposite over adjacent, so it's going to be y over x. Okay, now I can get the x and the y from the ordered pair. The r is different. I need to figure out the r. So the r is based on the Pythagorean theorem. The Pythagorean theorem, according to this triangle, says that x squared plus y squared equals r squared, and then I would square root both sides. And then I end up getting that r is the square root of x squared plus y squared. So if I knew x and y, I could get all the other values from that ordered pair. Okay, let's go ahead and try this so you can see what we're doing and what it might look like. So it says evaluate the 6 trigonometric functions of theta. They have given me an ordered pair. So even though they gave me a picture, I'm mostly going to ignore and use the ordered pair. Okay, so if I want sine is going to be y over r. I can see what y is. Y is 15 because this is the x, this is the y. The x is negative and that's fine. Okay, I need r, so I'm going to use the formula that r equals the square root of x squared Okay, and make sure you put parentheses on your -8 squared. Otherwise, it is not going to square properly. So I got the square root of 289, which is 17. So y over r is 15 over 17. Does that simplify? No, it's already simplified. Okay, so according to this, cosine is x over r. And what's x? X is -18. What's r? 17. And x is negative here, which is fine. Oh, I should note that r is always positive. It's just the hypotenuse, so we always keep it positive. Okay, tangent is, according to the rules, y over x. So the y is 15, the x is -8. And you notice that I'm not even using the picture, I just need the ordered pairs. Okay, now cosecant. What's cosecant the reciprocal of? Cosecant's the reciprocal of sine. Since sine is 15 over 17, cosecant is 17 over 15. Okay, secant is the reciprocal of cosine. Let's do the reciprocal of cosine. I'm going to get 17 over -8, and the negative can go on the numerator, the denominator, or the middle. Cotangent, reciprocal of tangent. So let's make this -8 over 15. Let's try one more. Okay, so they've drawn me a picture, which is lovely, but I only care about the ordered pair. So this is x, this is y, I need r. So r equals 3 squared plus -3 squared. I can do this in my head, huh? That's 9 plus 9, which is root 18. Oh, I can simplify that. That's 9 times 2, so it's going to be 3 square root 2. Okay, and it's positive, always positive. Okay, let's do sine. Sine is y over r. So y is -3. What's r? 3 root 2. Ooh, this is going to get simplified in a lot of ways. So I can see that the 3's are going to cancel already. I can also see that there's a square root at the bottom, so I need to multiply by root 2 over root 2. And some of you can do this in your head, and I'm okay with that. So I still have a negative at the top, and root 2 times root 2 is just 2. So the sine of theta is negative root 2 over 2. Okay, let's try and cosine. Cosine is x over r. What's x? 3 over r, 3 root 2. Okay, now the 3's cancel and leaves me with a 1 at the top. And then if I multiply by root 2 over 2, I get root 2 over 2. Okay, tangent is y over x. So negative 3 over 3, which is just negative 1. Okay, cosecant. Okay, cosecant is the reciprocal of sine, which I've simplified. Now I can flip this, but that's kind of weird because then I'm going to put a square root at the bottom. So I'm going to go ahead and flip this one. And then you're going to kind of figure out a best way to do this. So I'm going to flip this answer. It's because I don't want to have to rationalize it again. So this cancels. So I'm left with root 2 divided by negative 1, which is going to be negative root 2. Okay, now had I flipped this version, I would have rationalized it and I would have gotten the same answer. Okay, for secant, secant's a reciprocal of cosine. Okay, and the same, I can flip this, but I'm going to end up with a square root on the bottom. So I'm going to flip this one instead, so I don't have to have a square root at the bottom. So that was 3 root 2 over 3. And if you know that these are going to cancel, you can do it faster than this. So I get square root 2. Okay, and if I had flipped 2 over root 2 and rationalized it, I would have still ended up with square root 2. Okay, cotangent, I can flip negative 1, which is going to give me 1 over negative 1, or I can flip the original. Whatever works best in your head is going to be the best choice. It's still negative 1, because if I do 1 over negative 1 and I flip it, I still get negative 1.